Good morning. This is Mr. McMurray, and we're here talking about the integumentary system. How exciting! Okay, we're going to be going kind of over the answers off your worksheet, which you'll have a quiz on tomorrow. But also 1 through 15, I believe. Let's make it 16 to be on the safe side. But we will have a quiz over that material, and we'll try to go over that in this video. We may also have to do another video to finish it all. I'm going to be showing some things on the screen, some things I'm just going to be going over verbally. So let's start with number 1. It says, what does integumentary mean? Why is that a big yucky name for the integumentary system? Well, basically it means covering, okay? Because your skin's main purpose is that it covers your body, okay? Now it says, what are 6 ways that it protects your body? Because protection is probably the number 1 thing of the skin. All right, now this is on your note. In your book, so I'm not going to go over it a lot. But first, mechanical damage. This means bumping into things. 1, your outer layer cells have keratin, which is a very tough protein, and it protects you when you bump into things. You also have fat below the skin, the subcutaneous fat, because it's below the skin or cutaneous membrane, all right, which helps you to cushion blows when you hit things so you don't bruise easily. And you also have nerve endings and pressure receptors that say, hey, guess what? You hit something. Stop it. Or if it's something that's hot or electrical shocking you or something, says, ouch, let go of that. Okay, whatever. So that helps protect you and say, hey, I need to do something about that. Chemical damage, obviously. You always see things, people get acid dropped on them, they just melt or something. That doesn't usually happen. Your skin is fairly impermeable. In other words, it won't let things through, and it's just mostly dead cells and protein, so most things do not attack it very well. Okay, and so acids and bases, as long as you rinse them off fairly quickly, usually don't do a whole lot of damage. There are some exceptions. Nitric acid, which attacks proteins, which is what your skin's made out of, it will attack your skin pretty quickly. Okay, but other things, not so much. Okay, strong bases like cleaning supplies and stuff, same kind of deal. All right, bacterial damage, bacteria getting into our skin. The key thing is that your skin is solid. Okay, and so it makes a barrier that keeps things from coming in. That's the number 1 thing. If you get a cut, that's why you're supposed to treat it with antibiotic, because now you have an opening where things can get through. All right. You also, though, have some secretions on your skin that make it acidic, all right, and that inhibits bacteria from growing there and stuff, so that's also good. You also have white blood cells, or phagocytes. Phago means to eat. These are cells that eat or digest bacteria and stuff that they find, and they keep it from getting deeper. So if it's trying to go through your skin into your body, it's probably going to get picked up by those phagocytes. All right, so pretty good protection there overall from bacteria. All right, it also gives you UV protection. You have melanin, which is the dark pigment in your skin. When you tan, if you get a tan, it's because your body's saying, hey, you've been out in the sun too long. Let's make melanin, this dark pigment, that helps protect you from the UV damage. It makes like a little shield around your nucleus that protects it, and so they're made by cells called melanocytes. Guess what? They are cells that make melanin, or the dye, and so it helps protect you, makes like a little umbrella around your nucleus. All right, thermal. Obviously, you have cold and heat and pain to tell you when you're hot and cold and do something about it. Also, you have some muscles that help you to pull up your hairs on your arm and stuff to help lock in heat, but that one's not as effective on us because we don't have very much hair. And desiccation. The big thing is it keeps you from drying out. Because we have the keratin and there's some other glycolipids, which sugar-coated fats and stuff, they keep us from dehydrating. If someone has burn damage to their skin, one of the biggest things they have to worry about is dehydrating, because it lets that go away. So it lets all that liquids inside your body escape. And so that can be a problem. All right, so those are the 6 things that help protect your body. The second one says, besides protection, what are some other things that it does? 1, it controls how much body heat you lose or retain. Okay, to lose heat, you can have sweat glands, which soak up heat from your body to evaporate your sweat. Okay, you also have blood vessels that near your skin that if you run a lot or something, you get flushed. That's because your body's putting all these capillaries up at the surface of the skin trying to get rid of heat. Okay, by not letting, when it's cold, on the other hand, you tend to look more pale All right, because it doesn't have that blood in the outer skin trying to get rid of heat. It's trying to keep the heat inside your body. All right. It aids in excretion. We get rid of some waste products through your sweat glands. We don't think about, ooh, I got waste products on my skin when I sweat, but you do. It's just things like urea and uric acid that your body's trying to get rid of. It's not like, oh, you got urine on your skin or anything, but it is some of the same chemicals that would be found in urine. All right. Synthesizes vitamin D. Basically, when you're exposed to sunlight, then there are cholesterol molecules, basically different kinds of cholesterol type molecules that your skin converts into vitamin D. And they found that with too much sunscreen, if you wear sunscreen all the time, you might possibly be at risk of having a deficiency in vitamin D because you're not getting enough sunlight, especially young kids and everything. People are trying to keep from getting too much sun and damaging their skin or getting skin cancer, but you can overreact and then you don't get enough vitamin D. So that's also important. All right. Basically, let's see, number 4 says, how's a blister formed? Basically, if you have your epidermis, all right, which if we look over here, if it rips away from the dermis underneath it, okay, then you have this bubble up here and all these interstitial fluid, the fluids in between the cells rush in to fill in the space, and that's basically what a blister is. So basically the epidermis has been separated or ripped from the dermis below it, or maybe some of these layers of the epidermis have been separated, and then interstitial fluid is filling it up. And that's what that white liquid or clear liquid inside the blister is. Okay. Now, if it does enough damage that it does some damage to blood vessels, which are down here in the dermis, then you may have blood leak in there, and then you have what we call a blood blister. Okay, and that's the only difference. It's not any more dangerous. It's probably a little more painful because it probably means you've pinched it a little deeper and probably did damage to these nerves and stuff down here too. It's saying, ouch, that hurt. But there you are. Okay, whereas just getting a blister generally does not hurt that bad. All right, just for the record, what's the best thing to do with the blister? Probably poke it, let the stuff come out, but leave the skin there so it kind of acts as like a Band-Aid. If you rip that skin off, then you're exposing this dermis and tissue down here, which is very sensitive and is very much alive and has nerve endings and stuff in it, and it's going to be kind of painful until your body makes some more skin layers to replace that and coat it. So generally not a good idea to rip blisters off. Okay, don't do that. Okay, now it wants to know the top layers from the top to the bottom. So starting at the top, you have the stratum corneum. Corneum means hard. Okay, and so basically these cells are pretty much dead. They're just packets full of keratin, okay, waiting for their turn to get up to the top and flake off and become food for all the mites and stuff that live in your furniture and your bed and all that kind of stuff. But basically, this is all dead material up here. That's the stratum corneum. All right, the next one, in some parts of your body where you have very thick skin, like the soles of your feet, maybe the palms of your hand, anywhere you've been working and got calluses and stuff like that, there will be another layer in here that's is a clear layer called the stratum lucidum. Okay, and the stratum lucidum is, like I said, it's only there where there's very, very thick skin. It'll have an extra layer in there. All right, below that, then you have the stratus granulosum. You will notice stratum granulosum has all these little dots in it inside the cells. Those are why it's called granulated, okay, or granules. All right. Notice, though, they're on their way to becoming just keratin packets. The inside of the cells, you don't see a nucleus or anything like that. They're kind of breaking down and falling apart. All right. Then you have the spinosum. All right, spinosum. It's starting to get bundles of keratin and stuff building up in them, but these are probably still kind of alive, okay, and stuff like that. But they're starting to die. They're at the limits of where they have enough oxygen and food from the blood vessels down here to survive. Okay, so that's your spinosum. All right, then you have stratum basal. This is your bottom layer, and your bottom layer is they are actively dividing, making new cells and so forth. Okay, because they are close to the blood vessels and stuff down here in the dermis. Okay, and so they're still actively dividing. This is the part of your cell that replaces the layers above it. As the layers come up here, though, then they start breaking down and eventually become just the dead layers like that. Okay? All right, so that's number 5. Number 6. So it says the layer where keratinization begins, that's usually here in this venosus. Okay, that's where your pre-keratin is starting to form in there, and they're starting to die off, getting far away from the blood supply, so they're starting to become keratinized. B, the thickest layer, 75% of the epidermis, is this part up here, the corneum. Okay, that's where most of the outside layer of the epidermis is. All right. C, the layer where rapid cell division takes place, would be the basal down here at the bottom. Okay. The layer that's almost totally keratinized would be the corneum. Okay, it's getting close to it probably in here, but definitely by the time it's up here, it's almost all keratinized. That would be corneum. D is E, the waterproof layer that's resistant to water chemicals. That would also be the corneum. That's the outer layer that protects us. The lucidum for the next one, the layer that's only present where the epidermis is very thick, would be the lucidum, or that clear layer that sometimes exists right here. And finally, last but not least, is in the basal, or basali, if you want to say basali or basal, I don't know. I'm just going to call it basal for short. Okay, but anyhow, this is where you actually have melanocytes that make these melanin granules that give your skin's color. When we say they tan or whatever, that happens down here. All right, and so that's basically all of that. All right, this is Mr. Murray. Back to the drawing of your cell. Okay, so first of all, here we're going to have somewhere I cut off my recording. I don't know where, and I'm going to go back, so I'm going to just do it from here. Okay, on the drawing, you have these 3 main regions. You have your epidermis, which is the outer layer. Okay, you can scratch this layer without it bleeding or anything because there's not any blood vessels up here. Then right here at this border, the little wavy border there, that is the dermis. Remember, dermis is irregular, dense connective tissue, goes every which direction. The fibers go all these different directions. Okay, and so that's your dermis. And below that is your hypodermis. Hypo means below or less than, so epi means over or outer. So the outer layer above the dermis, and then you have the hypo or below the dermis. All right, starting at the bottom, working our way up. We have an eccrine gland, which is another fancy word for a kind of sweat gland. Notice it's all coiled up down here, and it opens directly on the skin, and so your sweat goes directly out on your skin. Okay, we'll talk about your oil gland over here. Notice it's associated with the hair follicle, and we'll talk about that later. All right, over here you have an adipose tissue, okay, or fat tissue. This is that subcutaneous fat that we talk about. Subcutaneous because it's beneath the skin membrane. Okay, hair root. If you look at the bottom, this is your hair root. It has a nerve ending there. This is why if you pull hair, if you pluck hair, you're going to be pulling at that. Now, it probably breaks up here somewhere, but you're going to be pulling on that nerve, and so it hurts when someone plucks your hair. If you just cut the hair, this is all dead cells up here, so that does not hurt. But if you pull on it, it's going to hurt because it's going to pull on these nerves. All right, now this little bulb where the hair is attached here, this is the follicle. So we talk about your follicles, your hair follicles. Okay, that's this area around it, a little pocket that surrounds the hair. All right, there are nerve endings that go to this muscle. This is called the erector pili muscle. If it contracts, it makes your hair stand up, which traps air and helps keep you warm, although most of us don't have hair. Some of them hardly have any. But anyhow, it does help a little bit, but not so much for us as it does animals with more hair. All right, the sebaceous gland is the oil gland right here. Notice the oil gland always associated with hair. That's why when the oil goes out here, you have oily hair. Okay, well, that's why. It also goes out on the skin once it gets up here, but it's really associated with the hair gland, and that's why it's there. All right, and then you have the dermal papillae. This is the little wavy part where the dermis meets the epidermis, and this waviness is what gives you the little ridges on your fingerprints. Okay, and finally, the top layer of your epidermis is your stratum corneum. All right. Now, if you look at number 8 real quick underneath that, how long will it take for your epidermis to completely replace itself? Is anywhere from 24 to 45 days. It just depends a little bit, but as these lower layers of the epidermis, the basal keeps making more cells, pushing them up, these wear off, and so about once a month you get a new layer of skin. Isn't that nice? So you have completely new skin. Your skin is only a month old, no matter how old you are. All right, we'll stop there and we'll come back on the next one.